Hello and welcome to this video. In this video, we will study circular linked list. So I'm using a singly linked list kind of data structure here. So we have only next pointer. You can implement a circular linked list also with the doubly linked list as backend with a pre pointer. But for simplicity, I have used this and I have split the driver program, that is menu is here and main function is here, and the data structure implementation is in a separate file so that in future if we need we can use it as a library. So the property of a circular linked list structure is compared when you compare it with linked list, the difference is that the last node of a singly linked list is null. That I mean to say the next pointer of last node is null in a linked list. But in a circular linked list, last node's next pointer points to the head. So it becomes quite useful when you want to implement something like a circular buffer or ring buffer kind of thing. It becomes very handy. We will see usage of circular linked list in future when we implement problems based on circular linked list. So let's go through the code. So as always, we have a menu so that we know what actions we need to take. And we start with head pointer as null, option as 0. We print menu, read the option, and then if it is between 1 and 7, then we choose one operation, and accordingly we pass head pointer. If we want to modify the head, then we pass ampersand, otherwise we simply pass head, and we repeat this till something other than 1 and 7 is entered on keyboard. Now let's go through the implementation functions one by one. So we have search. Search is simple, just like linked list. We copy the head pointer to a pointer called first, and we take a number for input. If head is null, then we return immediately. We take input which is to be searched, and we run a do while loop till head is equal to first. So after first iteration, head will not be same as head if it has more than one element. So if the head's data matches with I, we print that the position is position of the data. Now note that it is based on position 1. Okay, so initial value of position is 1 here. Print is simple. We if head is empty, we return to print head, and we then go on changing head to head next. So we move from one pointer to another till head becomes equal to first. Now we look at addition at beginning. So we pass pointer to head because we want to modify head. We copy the address of head in a temporary variable. We have an integer I which will be used uh, for storing the value, and our iterator pointer is null. We allocate a piece of memory and store it in IT. We read value of I here, and then we copy that value in IT data. You can skip this I here, and instead of scanf on I, you can simply store it in IT data. One more point worth noting is that this malloc should succeed. Okay? It might be the case that IT is null if malloc fails, so you have to handle that error case, which I have not handled here. Now what I do is I point next of IT to head. So head might be null. We don't know. But in any case, we point the next pointer of nodes to head. Now if head is not equal to null, we go through the list, and in the end we point the next of this temp variable to IT so that it becomes head. The last link is here. Otherwise, we simply point next of IT to itself. Okay? And in the end, we assign the head pointer to IT so that this is newly inserted node becomes the head. Now we look at addition in between. So like previous one, we have a temp pointer, we have a q pointer where we have taken the head, and there are two variables ij and position, three variables 0. We take the position. If position is 0, then it is addition at beginning. If after this, if we find that q is null, that is our head pointer is null, and position is 0, okay, then for null list position must be 0. If it has reached here, that means position is not 0, but our q is null, so we return here, because if position is not 0 and list is empty, then we can't insert. And then we allocate and we iterate till we reach the position, and then we take the temp variable, which is our newly allocated variable, and points it next to the q next, where we want to insert in between, and q's next we point to temp. So how it works is, suppose we have two variables 4 and 5, and in between you want to insert 3. So 4's next is pointing to 5. So what we do is, we take 3, we make 3's next point to 4's next. So 3 will point to 5. And then we take this 4's next and we make it point to 3. So that's how we sandwich our value in between two values. Okay, it's just pointer manipulation. And then we copy the data and we return. However, there is a case that it reaches the end of the list. In that case, if j becomes equal to position, then it becomes an append operation. Now, one thing you should notice here is that if this is the case, then append will prompt again for input. You will see it very soon. So if this is not the case, then it is out of range. Position is out of range if we have reached here. So we free the temp variable and leave. Now what I was talking about is this append operation. So what happens in append is, it asks for a number to be input, but we have already taken number as input, okay. But in this case, if append is called, then there will be two scans and the last one will hold. So in append operation, we iterate like linked list till we reach the head of the pointer, and then we insert the node. So it is pretty easy to understand. Count is easy, just like print. It will go through the loop, and it is, if head is not equal to first, we go on increasing the count, and eventually we print the count. Now we look at delete. Now in this case, we have a temp pointer where we have copied head. So head might be updated, we don't know. Head might get updated or might not get updated. If head is null, then there is no elements to be deleted. Otherwise, we scan for keyboard input for one element to be input. Now temp is head. So if temp data is I, and if temp data is temp next, so there is only one node. That means there is only one node. So if we free temp, we make head to be null. Now this also implies that you are deleting the head node. So head needs to be updated. So we copy the temporary node, that is the head node, into variable to delete. Now we go on iterating and we find out this head node. Okay. So head would be temp next in this case. Note that in this case there is more than one node. There are at least two nodes. Okay. So in this case, we find the head pointer and we manipulate the pointers and we make this free to delete. Now, in the case the node to be deleted is not head pointer, then what we do is we go till we iterate till we find the head pointer in the loop. Now, in between, if you find the temporary data, then we manipulate the pointer and free temp and return. In this case, we use one extra variable q and one variable temp to preserve two nodes. Now in case if it is last node to be deleted, then we make the next pointer point to temp next and we free temp. So that's it. It's quite simple and straightforward to implement. If you have studied the linked list carefully, it is just about maintaining the last node's tail pointer. That is the only extra job you have to do in a circular linked list. So a lot of programs which I have written, stack or queue or circular linked list, these three, when they are based on linked list, it is pretty straightforward. So if you have understood linked list carefully, then all these will be easy to understand. Let's see this program in action. So we compile, our compilation has gone fine. We run the program. So we add an element in the beginning. So let's say we insert 1 and then we print list. We have got head pointing to 1 and this extra arrow means it is going back to head. Now we add something at position 1. Now note that this means an append operation because there is only one element right now. And if you think in terms of zero based positioning, then it is at position 1. For example, if you see add in between, in this case I made it based on 0, but in this case the position was 1. Search is different than addition in between, so that you have to take care of. Or you might choose both as position 0 in your code. So suppose we want to enter 3, but as I said, it will call append function. Now this is appends message. Okay, so if we enter 5 here, then 5 will be appended. This 3 will be discarded. So we enter 5 and there we go. It has been inserted. So you see, after 1, 5 has been inserted. Now let's repeat this operation again and we inserted position 1. That means element will be inserted between 1 and 5. So let's say we insert 3. Then we print this. So we have 1, 3, 5. Now let's insert an element at the end, which we have already executed by choosing position 1 earlier. Let's say we want to insert 2. So let's see the output. The 2 has been appended. So we have exercised all three operations. Let's count this. The count is 4. So there are 4 elements and count is 4. Let's search for an element. We want to search 4, but 4 is not in the list. So it says 4 was not found in the list. It is linked list rather than linked list. It should say circular linked list. Let's say we want to find 5. So 5 is found at third position. So this is first, second, and third position. So in search, we are using 1 based indexing. And let's now we want to delete something. We delete from head. So after deleting from head, we have 352. We want to delete the last element 2, or we first delete 5. Okay, so that we get an in between deletion. We print again. So we have 3, 2. Now we delete again. We want to delete say 2. So the value at the end is deleted. So looks like this is working. If you find any error while executing this logic, please let me know in the comments. And with this, we come to the end of implementation of linked list. I mean, we have covered linked list, circular linked list, and doubly linked list. More variation of linked lists will be covered in future videos. But starting from next video, what I will focus on is sorting algorithm. There are lots of sorting algorithms which we can implement, and we need to understand their complexities. And there is also a concept called stability of sorting algorithm. All this we will see in the next videos which will come. So if you have found this video useful and informative, then please subscribe to the channel and like the video so that it can reach many more people like you, and they can also benefit from this. So because that's how YouTube algorithm works. The more likes, the more views are there, there is more chance of it appearing in someone else's search or suggestions. So to help people like you or other students, please like the video and subscribe to the channel. So with this, I'll wrap and see you in the next video with sorting. Happy programming. Enjoy.